minds ignore this when they're doing calculations, and that's not okay. So what is a significant figure? Okay, well, that word significant means something has meaning, it has value. So these are the numbers that have meaning, that have value. So let's say I want to measure this nail. So how long is that? Okay. And by the way, when we have class, I will often ask you a question, and I want you to answer the question just to yourself. You know, we won't take time for everyone to, you know, type in the answer or speak the answer, but, you know, you should be active, so you should be saying to yourself, okay, how long is this? And so you should be saying that this is about 2.85 centimeters. Now, some of you maybe said 2.84 or 2.86, but everyone should have said 2.8 something centimeters. Okay, so this idea of significant figures. Whenever I measure something, that last digit is always uncertain. You know, like I said, sometimes somebody might have said 4, or somebody might have said 6. Okay, but all of the digits are significant. So we could ask two questions. Okay, for this number, how many significant digits, how many significant figures are there? Well, all of them are significant. They all have meaning. So this one has 1, 2, 3 significant figures. Okay, how many are certain? Well, only 2. Okay, so we first need to be able to determine how many significant figures does a number have. And you should already know how to do this. I just put these rules here as a review. We're not going to spend a lot of time on it, but just kind of to refresh your memory. Remember that if a number is not 0, it's significant. If you have zeros after the decimal point, okay, like you see for these two, then those zeros are significant. If you have zeros between other numbers, those are significant. So, you know, these are all significant. These are significant. If the zero's a placeholder to the right of the decimal, so like here or here, those are not significant. So we only look at, you know, the last numbers to see what's significant. But remember, this one at the end is significant. And then if you have a number that ends in 0 to the left of the decimal, like these two, 17,000 and 1230, we actually do not know if those are significant or not, because we don't know how the measurement was made. Okay, so those are the quick rules. Let's just practice a little bit. And an easy way to determine significant figures is you just start at the left with the first non-zero digit and you count. Okay, so we've got a bunch of numbers here. Okay, so for this one, how many significant figures? Okay, well, answer's in your notes, but there are 4. Okay, how about this one?
3.
Okay, 3. Okay, how about this one?
3.
Okay, this one is 3. Which 3 are significant? Well, remember, these are not significant. So it's these right here that are significant. Okay, how about this one, the 9.0 centimeters?
2.
Okay, that one's 2. How about 1.0 times 10 to the minus 8?
1, I think.
Okay, well, both of these are significant. So this has 2. Now, what about this minus 8? Is that significant? Well, remember, what does this mean when a number is written with this exponential notation? Well, that means 0.00007 zeros, 1 0. So remember, all of these zeros here are just holding their place. Those are not significant. So the 2 significant ones are these 2 right here. All right, and then this last one, 700 meters. Okay, well, this is that case of the bad notation. I really don't know how many significant figures because I don't know how this measurement was made. So let me show you a little bit what I mean by that. I don't know how it was made. Let's say I want to measure this volume, and I have, different ways to measure the volume. And of course, if I measure it this way, I only would get 2 significant figures. Here, I'd get 3, and here, I would get 4. So the way you make the measurement determines what's significant, or determines how many significant figures you will have. Another example with length. This way, I only get 2 significant figures, but here, 3. Now, when you have non-zero numbers like all of these, then it's obvious how many significant figures. The problem is, when we end in 0. So let's say I have a temperature here, and I want to measure this temperature. What would that number be? Well, if we look at the significant figures, this would actually be 30.00. Okay, so we can actually measure this with 4 significant figures. Now, if you just say, oh, it's 30, well, that means that was done on a different thermometer. Then your marks are either 10 or even 100 apart, depending how you made the measurement. So again, the problem is when it ends in 0, I don't know how the measurement was made. So to avoid this error, we have to use the exponential notation. So going back to that 700. If I write it like this, then I know very clearly how many significant figures. Well, that one has 3. Okay, if I write it like this, then 2. And if I write it like this, then only 1. So anytime a number ends in 0 before the decimal point, you need to use exponential notation. Now, one note about exponential notation, it should always be written with 1 number in front of the decimal. So this 700, you cannot write it like this, 70.0 times 10 to the first. This is incorrect notation. It needs to be written in one of these formats. Okay, so that's significant figures. Now, the reason I'm talking about this is because we will be doing calculations in this class. This class does have a lab. So I guess those of you in China will be doing the lab, so you will be doing some measuring. But for those of us here in the lecture, we'll just be doing calculations. So we have to know, how do I deal with significant figures in calculations? Okay, and again, you should know this, but I'm just reminding you so that when you do calculations, you pay attention to this. All right, so let's say that I measure something and then I do calculations. So the significant figures in that calculated number is always dependent on the measured numbers. Okay, for example, I have a cube and I measure the side, it's 1.35 centimeter, and I want to calculate volume, which is the side cubed. So I put it in my calculator and I get this number here. So I measured the number, measured the side, and I have how many significant figures? Okay, well, there's 3. And then you put it in your calculator and you give me this number, which has 7 significant figures. Okay, now, do you think it's reasonable that you can measure and have 3 significant figures and then suddenly give me a number with 7? No, that's not reasonable. Many of these numbers, they have no value. They're meaningless. Okay, so how many should you give me for the answer? Well, let's look at the rules. So the first rule is for multiplication and division. So for this one, your answer will always have the same number of significant figure as the measured number with the fewest. So going back to this example, if I measure this and I have 3 significant figures, then my answer should have 3 significant figures. So your answer you should give is 2.46 cubic centimeters. Let's look at another example. Let's say I have some water or a liquid and I have 25 cubic centimeters and I weigh it and it's 25.624 grams. And then I want to calculate density, which is grams divided by cubic centimeters. So my calculator gives me this number. Now, what should you give as your final answer? So remember the rule. We look at how many significant figures for this number. Okay, there's 2. How many for this number? There's 5. Okay, so my answer should have, remember it's the number with the fewest, so my answer should have 2. So you should give your answer as 1.0 grams per cubic centimeters. Okay, so that's multiplication and division. All right, then the next rule, this is a different rule if you're adding and subtracting. Then the rule is the answer is determined by the number with the fewest decimal places. So for example, I want to do a total mass. So what I have to look at is each of these numbers, how many numbers behind this decimal point. Okay, so this first one, 10.21, has 2. The 0.2 has 1. And this one, 0. Okay, so what do I give as my answer? Well, remember, whichever one has the fewest decimal points. So this one has 0, which means my answer should have 0 decimal points. So you should give as your answer 266 grams. Now, this is very hard for you. You say, oh, but I want to just keep a few extra numbers. No, they have no meaning, because this has no decimal points. It's meaningless to give an answer with decimal points. Okay, so there's multiplication and division is one rule. Addition, subtraction is the second rule. And then there is another rule that's a little bit harder. It's for logarithms. So remember, logarithms are those things where we're raising things to base 10 to a power of x. And there's different ways to represent this. In our class, we will always represent the log as this, L-O-G. So remember, the log of 10 to the 5th is 5. The log of 1 is 0. The log of 10 to the minus 2 is minus 2. And then there's also the natural logarithm. That's when you're working with a base e. And again, in this class, we will always use this ln for the natural log. Okay, so, and the natural log of 10 is 2.303. So what do we do for significant figures? Well, this one, you take the number of significant figures in the original number, and then we're going to use that number of digits after the decimal point. So let's look at some examples. Let's say I have this is my original number, 12.8, which has 3 significant figures, and then I take the log. So for significant figures, I'm going to need 3 after this decimal point. Okay, another example. Here's another number. I take the log, and my calculator gives me all of these numbers. So what should I report as my final answer? So remember, what's the rule? We look at the original number, and it has 2 significant figures. So that means I need 2 after the decimal. So you should give your answer as 4.92. Okay, now what about if I have to undo the log, do an inverse log? That might be an example. I have a pH of 4.32 and I want to know hydrogen ion. So that means I need to do 10 to the minus 4.32. So I put that in my calculator. And by the way, you need to make sure you can do this math on your calculators. Take logs and inverse log. You have to do that in this class.